For solving equations, we're going to start out with quadratic equations. A quadratic polynomial has a highest degree of 2. We usually write a quadratic polynomial as ax squared plus bx plus c. Now, polynomials are not equations. They are expressions. We can turn it into an equation by making it equal to something. But here, quadratic polynomial, we have this expression. Our highest degree is 2. Degree is talking about the highest exponent on the variable. B could be 0, C could be 0, but A cannot be 0. If A is 0, then we have a linear equation, bx plus c, and that's not quadratic. A quadratic equation in the variable x can be written as ax squared plus bx plus c equals 0, where a is not equal to 0. So now we've created an equation with that quadratic polynomial. This is called the standard form for a quadratic equation. We're talking about quadratic equations now, and then fast forward a few chapters and we'll be talking about them again. Factoring is only one strategy we can use to solve quadratic equations. There are 3 others, so we'll save that for the later chapter on quadratic equations. Right now, let's work on factoring. So which of the following are quadratic equations? You might need to rewrite them so that they're in this standard form, ax squared plus bx plus c equals 0. Again, pause that video, see if you can try it on your own, and then come back and we'll talk about it. It's really important for your brain and your learning to try things out on your own. See if you understand it at first, and then go back, check it, and if you need to, correct a mistake. So let's take this first one. X squared plus 5x equals 14. Well, in our quadratic equation, we were supposed to equal 0, but this one doesn't. However, if we subtract 14 from both sides of the equation, we can write this equation as ax squared plus bx plus c equals 0. A is 1, b is 5, and c is negative 14. And so yes, we have a quadratic equation. How about the next one? 3x plus 2 equals x minus 4. Let's play the same game as before and try to get everything on one side so that it equals 0. We can subtract x from both sides, add 4 to both sides, and we get 2x plus 6. But now, if I try to match up a, b, and c to see if it's a quadratic equation, b is 2, c is 6, but I have no x squared term, so a would be 0. A is not allowed to be 0, and we call it a quadratic equation. That's not true. 2x plus 6 equals 0 is actually a linear equation. This problem is not quadratic. Last one in this row, x to the 3rd power minus 4x plus 5 equals 0. Here's where that attention to detail is extremely important in mathematics. If I try to line up my quadratic equation in standard form, ax squared plus bx plus c equals 0, at first it looks like I have the right number of terms in the right order with the variables. But look closely, particularly with this first term. What do you notice? Do you see that the exponents are different? That's not x squared that we're given, it's x to the 3rd power. That power is important. Quadratic says the highest power is 2. So this is not quadratic. We actually call this one a cubic equation, x cubed. You don't have to worry about that right now. We're going to talk about it later on in the class. but this is not quadratic. No x squared variable, with square being the highest power. Continuing on, x squared equals 16. Is it quadratic? Remember, quadratic equation says we need it to equal 0. So let's subtract 16 from both sides. I try to line up ax squared plus bx plus c equals 0. I see that a is 1 because there's 1x squared. C is the number by itself, negative 16. B is 0. There is no x term. That's okay. The only coefficient that cannot be 0 is a. And we don't have a 0 for a. So this is quadratic. We've got the x squared. We've got it equal to 0. Those are the minimum elements we need for a quadratic equation. How about number 24? X squared plus 4x equals 6 plus x squared. It's got x squareds in it, so it looks promising. But remember, we have to put it in standard form. We have to get the whole equation to equal 0. So let's subtract 6 from both sides. And then let's subtract x squared from both sides. X squared minus x squared is going to give me 0. And we lost our x squared term here up front. So this is not quadratic. And then how about the last one in this group? 2x squared minus 15 equals x. Again, make it equal 0. 2x squared minus x minus 15 equals 0. And if I try to line them up, a is 2, b is negative 1, c is negative 15. This is quadratic. We can identify quadratic equations. That's important because that's how we're going to solve polynomial equations. Let's talk about the zero factor property. When the product of two or more numbers equals 0, then at least one of the numbers is 0. Or we can rewrite it. If a times b equals 0, then a equals 0 or b equals 0. This is what we use to solve quadratic equations. We're going to factor. So notice 3x squared plus 12x equals 0. We want to solve that equation, but we have the factored form in number 15. Scroll back to your first page, and you'll remember that we factored this as 3x times x plus 4. So I'm going to just drop that in. 3x times x plus 4 equals 0. According to the zero factor property, two numbers multiplied together to give me 0 means that one of those two numbers equals 0. So we can take each one of these factors and set them equal to 0 and solve for x. So I'll take the x equals 0. X plus 4, that whole thing needs to equal 0. But this time, solve that equation for x. We can subtract 4 from both sides, and we get x equals negative 4. So negative 4 and 0, if I were to use those numbers and plug them in, one at a time, I'm going to end up with 0. Okay, can you scroll back to that first page? Check out numbers 13 and 14. X equals 0, x equals negative 4. When we plugged them in, we got 0. And that is exactly how we solve these polynomial equations with factoring. A couple more definitions for us, then we can move into solving these equations. So a polynomial equation is an equation with a single term or a sum of terms in which all variables have whole number exponents, 0, 1, 2, 3, etc., and no variable appears in a denominator. We've been working with these. This is what we've been doing to factor. We've been using polynomial expressions and factoring polynomial expressions. Now we're going to have equations, so there's an equal sign in them, and we need to try to solve them. We already know how to solve linear equations, which is the simpler type of polynomial equation. If we're solving 3x plus 2 equals 7, the idea is to try to get the variable by itself on one side of the equation. So we need to undo the operations that are being done to that variable. Now remember when we talked about the order of operations just a few minutes ago? Parentheses, exponents, multiplication and division left to right, addition and subtraction from left to right. Some people remember this with PEMDAS, the first letters of all the operations. Some of you may have learned this as BODMAS. It's the same idea. Brackets, order is another word for exponent, division and multiplication, addition and subtraction from left to right. Some of you may have even learned it as, please excuse my dear Aunt Sally. That's how I learned it. But the important thing about the order of operations is when you are simplifying, you start at the top with parentheses and you work your way down this order of operations. You start with the most complex operation, parentheses, and then you go to the next most complicated, exponents. Exponents is repeated multiplication. So then we drop down to multiplication and division, which is extremely closely related to multiplication. Multiplication and division, multiplication is repeated addition. And then we drop down to the addition and subtraction and do that out to finish the problem. But when you are solving, you start at the bottom and work your way up. And solving's not so straightforward. You might work your way up and there might be some things that we need to do in the middle. But the idea with the solving is we need to pull apart the operations that are being done to the variable. Okay, super long review for solving linear equations. So I see that I have this 3x term plus 2 equals 7. So I'm going to start with the plus 2 part and make that go away. Get rid of it. Subtract 2 from both sides. When we subtract 2, 3x equals 7 minus 2 will give me 5. And I have 3x equals 5. Again, focusing in on that x. The operation being done to the x is multiply by 3. So I want to do the opposite operation, divide by 3. X equals 5/3 would solve that linear equation. Polynomial equations are a little different. For polynomial equations, because we have an x squared term and sometimes an x term, we don't get to try to isolate that x variable. It doesn't work the same way. Instead, we're going to make use of that zero factor property and factoring. So solving polynomial equations, and these are equations specifically with degree 2 or higher. So their highest exponent is 2 or higher than 2. Equations with degree 2 or higher. So we'll start out with the first step. Write the equation in standard form. Standard form, essentially for polynomial equations, just means we want to make sure it equals 0. So if there are terms on both sides, add or subtract so that all the terms are on one side of the equation and the other side of the equation equals 0. The second step, we completely factor the non-zero side. The side with all the stuff in it, factor it. Find the greatest common factor. If there is one, count the number of terms. 4 terms, use grouping. 3 terms, use the AC method. 2 terms, check to see if it's a special product. And then the third step for factoring is always check your factors again to see if you can factor them more. Step 3, we're going to make use of that zero factor property by setting each factor equal to 0. So like we did in that first example with 3x squared plus 12x equals 0. Set each factor equal to 0, and then we solve. We're solving all of the small linear equations that are going to come from setting these factors equal to 0. And I'm going to add a little note here. You will have the same number of solutions for your variable as you have the polynomial's degree. This is something that's called the fundamental theorem of algebra. Every polynomial, if I set it equal to 0, will have the same number of solutions as the highest power on that variable. So remember that 3x squared plus 12x equals 0? We had two answers, 0 and -4. And then the last step, check the results in the original equation. Plug them back in, make sure that they equal 0. Make sure that they work. I'll leave all the rest of the examples in the next lesson.